Hello, my name is Lindy Humphrey, and this is my Lab 4, for Physics 2, bar magnets. To introduce this lab, the purpose was to measure the distance dependence of the magnetic field due to a small bar magnet, and to compare our measurements to the distance dependence predicted by the equations for the on and off axis magnetic fields. We had to also download a magnetometer app for this lab, and the results were solving for mu and to solve for the magnetic dipole moment. And just to go ahead and put in some assumptions or errors, some assumptions that we made was the bar magnets act as a magnetic dipole, the magnetic field falls off as distance increases, and then some errors was that some of the electronic objects skewed the magnetic meter, or the exact location was not found precisely just by human error. And then some main physics principles is the Biot-Savart law, the magnetic field of a dipole, the distance dependence formula, and then I went ahead and corresponded each of their equations that we had to use for this lab and their definitions that we had to go by. That includes relating the magnetic field at a point to a tiny circuit element. A magnetic dipole is closed at the circulation of an electric current system, and the magnetic of a magnetic field due to a bar magnet falls off with distance. And then here's a picture of our lab in class. As you can see, we have the tape on the phone after we have identified the point on the phone for where our sensor was, and then we were moving the magnet back and forth to get the different values. Some of the steps of this lab that we did in lab was to orient the phone to make the magnetometer orthogonal to Earth's magnetic field, which is the direction of the yardstick, or up against the yardstick. We had to find the location of the magnetometer chip on the phone, which is identified by the tape, and measure the distance between the magnetometer and the bar magnet for on and off axis, which is after this part. And then here was our chart that we had to fill out for this lab. Up the top left, you can see the distance measurements for the different strengths. We had to do this 3 times just to get different averages and have it more precise, which took a while as well. And then the very bottom was the off-axis field measurements that we had to do, which required a little bit different calculations. And then up on the right was the linearized plot of the averages that it plotted for us as we filled in the data to kind of show the errors and to kind of show the average position of everything. And then we used the equation down at the bottom. I went ahead and wrote the slope and the formula, and then identified the formula that we're going to be using for calculations. And then here was our calculations to solve for mu and to solve for k, using some of the laws and using what the graph told us. Plugging that into our code, here's what we got for our code, and then what the code gave us to kind of show the bar magnet and the way it was moving on axis and off axis, because we had to identify the difference when it was off axis as well. And then some final questions for this lab is, what if you had oriented your experiment to compensate for magnetic north and instead laid your meter stick at some intermediate angle with respect to Earth's magnetic field? How would your results have changed? And then the answer to this is the Earth's magnetic field would interfere with the bar magnet's magnetic field and then skewing the results, because obviously the phone going a different direction would interfere with the magnetic results. And then what if we stuck 2 identical magnets together end to end and run the experiment again? How would we expect our measurements to differ? And then the magnetic field magnet would double, but the direction would stay the same, because obviously with different strengths and different magnets, these would stay the same or drastically change. It just depends. And that's it. Thank you so much.